Heron's formula. In this module, you will learn finding the area of any triangle using the Heron's formula. Four friends, Sid, Neil, Ria and Sophie, are studying in a group at Neil's home. Neil's father gives triangular cutouts to each child. He asks them to find the area of the triangles. All the children start finding the area. Sid identifies his triangle and says it is a right triangle. Do you know how to find the area of a right triangle? Sid finds the area of his right triangle using a formula. The area of a right triangle is half the product of its base and height. Then Ria excitedly says, "This is an equilateral triangle because each side is 8 centimeters. I know the formula to find the area of the equilateral triangle. It is √3/4 into side square." Then Sophie says, the given triangle is an isosceles triangle because its two sides are 17 centimeters each. I can find the area of an isosceles triangle, but first I need to find the height of the given triangle. She recalls how she can find the height of an isosceles triangle. Can you help her? Take the midpoint of the unequal side BC and mark it as D. As the length of BC is 16 centimeters, both BD and DC are equal to 8 centimeters. Join A and D. We know that the triangles formed ADC and ADB are right triangles. So, by using Pythagoras' theorem, we can find AD, that is 15 centimeters. Now, she easily finds the area of the isosceles triangle by applying the formula of half into base into height. Neil is still confused how to find the area of the triangle given to him. Then he discusses with his friends and says, "This is not a right triangle." Sid replies,
"Yes, this is not a right triangle, as no angle of this triangle is 90 degrees.
Neil further says,
"This is neither an equilateral triangle or an isosceles triangle."
Sophie added,
"This is a scalene triangle, as all the sides are of different measures."
Neil asks,
"How can we find the area of a scalene triangle?"
They all start thinking. Do you know any method or formula to find the area of a scalene triangle? They are asking Neil's father. He says that they can find the area of this triangle if you know its height. To do so, you need to construct a perpendicular on the base from the opposite vertex. This is a time-consuming task. To overcome this, we can use a formula. Neil's father asks, "What do you think? You are the only person who came across such a problem?" "No. Let's go back to history." The great mathematician Heron was also interested to find the area of any triangle. He derived a formula for finding the area that can be applied to all types of triangle. Neil's father explains, "The formula given by Heron for finding the area of a triangle is known as Heron's formula. It states that the area of a triangle is equal to square root of s multiplied by s minus a multiplied by s minus b multiplied by s minus c, where a, b and c are the sides of the triangle and s is the semi-perimeter, that is, half of the perimeter of the triangle. This formula is helpful where it is not possible to find the height of the triangle easily. Let us apply it to calculate the area of Neil's triangle. First, we find the semi-perimeter of the triangle. That is, S is equal to 11 plus 13 plus 8 divided by 2, that is equal to 21 centimeters. Now, we apply the formula to calculate the area. The square root of 21 into difference of 21 and 11 into difference of 21 and 13 into difference of 21 and 8. In the next step, square root 21 into 10 into 8 into 13, which is equal to square root of 21840. That is equal to 147.78 centimeters square. In this way, we can easily find the area of any scalene triangle. Now Sid asks, Uncle, can we find the area of other triangles by applying this formula as well? Neil's father replies, Yes. Now using Heron's formula, you can verify this fact by finding the area of other triangles you have. We have 3 triangles. Using Heron's formula, the area of right triangle is 30 centimeters square, which is the same as we found the area of the same triangle by applying the formula for a right triangle. Similarly, the area of equilateral triangle is 16 root 3 centimeters square, which is the same as we found the area of the same triangle by applying the formula for an equilateral triangle. Similarly, the area of isosceles triangle is 120 centimeters square, which is the same as we found the area of the same triangle by applying the formula for an isosceles triangle. Now, Sid, Ria and Sophie are thanking Neil's father for sharing about the Heron's formula. Let's recap. Here we have seen the new formula for finding the area of any type of triangle, that is, Heron's formula. It states that the area of a triangle is equal to square root of s multiplied by s minus a multiplied by s minus b multiplied by s minus c, where a, b and c are the sides of the triangle and s is the semi-perimeter, that is, half of the perimeter of the triangle.